Okay, so welcome to CBY610, Module 1, Week 1. Basically, what we're going to do for this first module is really introduce some of the basic concepts, a little bit of historical background about the field of information security, and then kind of talk about some of the key processes or key programs or initiatives that you might see in the field of information security or cybersecurity. Think of Week 1 really as a primer for what we'll be talking about for the rest of the term. Basic learning objectives are basic things that we want to make sure that we accomplish during this presentation. We want to definitely give out some sort of definition of information security, look a little bit about the historical perspective of computer security, how it evolved into information security, look at some key terms, critical concepts, talk about the phases of the security system development lifecycle, describe the role information security professional within an organization, and then, kind of wrap it up and give you a good summary of where we're going to go from there. So basically, we want to look at, try to define what security is. And Jim Anderson in 2002 said basically information security is in today's enterprise is a well-informed sense of assurance that information risks and controls are in balance. And that's really the risk management, risk analysis process in a nutshell. Security professionals must review the origins of where we came from, really understand the impact. So we're really going to look at, where was the field when it started, and then how has it impacted our understanding of information security today. A quick history of information security, really began with the need for computer security began with the need to secure the physical locations of hardware from outside threats. And we're talking really about mainframe computers here. Too big to pick up and carry away. We were really concerned about, making sure that we restricted physical access to those mainframes, in order to control the security of that particular machine. Shortly after or during World War II, groups began developing code-breaking computations, which is where we really moved into the first modern computers being developed. Things like badges, keys, and facial recognition of authorized personnel were really used to control access to sensitive military locations. But in contrast, information security during the early years was very rudimentary and mainly composed of simple document classification schemes, top secret, secret, so forth and so on, which coincidentally or not so coincidentally, but as a matter of fact, still remains in effect. Today we use discretionary access control in relationship to files and folders within computer systems as well. There were really no application classification projects for computers or operating systems at the time because primarily the threat to security were physical theft of equipment, espionage against products of the system, and of course sabotage. Little picture here, the enigma here. More properly, this is an artifact that is part of the study of cryptography, which we'll talk about a little bit later. But really, this really, if you look into the background and understand the history of the Enigma machine, really the security of this device was the fact that they tried to make sure that it did not fall into the enemy's hands, because once an individual had access to it and a couple of other key pieces of information, then they were able to, break the code that was made this such an effective cryptographic machine. If we look at, probably the earliest we can really look at is the 1960s. The Department of Defense's Advanced Research Procurement Agency, or ARPA, began examining the feasibility of redundant networked communication systems, which was really designed to support the military's need to exchange information. And if we look at and try to identify an individual who perhaps might be classified as the founder of perhaps what we might call the internet, is Larry Robertson. He developed the project from its inception, and it was originally called ARPANET. Internet grew in popularity in the 70s and 80s, during the next decade anyway, and so did its potential for misuse. In December 1973, Robert Metcalf indicated that there were some fundamental problems with ARPANET security in that individual remote users did not have sufficient controls and safeguards to protect data against unauthorized remote users. There were no safety procedures for dial-up connections to ARPANET. User identification and authorization to the systems were basically non-existent. Phone numbers or access numbers or phone numbers were widely distributed and openly publicized on the walls of, phone booths and restrooms, giving hackers easy access to ARPANET system. Much of the focus for research on computer security centered around a system that was called Multics, or Multiplexed Information and Computing Services. In mid-1969, not long after restructuring the Multics project, several of the key players created a new operating system called Unix. And while Multics system had planned security in multiple security levels and passwords, the Unix system did not. In the late 1970s, the microprocessor brought in a new age of computing capabilities and security threats as these microprocessors were able to be networked. If you look at the field of information security, it really began with the RAND report R609, which was sponsored by the Department of Defense, which attempted to define multiple controls and mechanisms necessary for the protection of multi-level computer systems. The scope of the computer security grew from physical security to include things like safety of the data itself, limiting random and unauthorized access to data, really the first look at access control, involvement of personnel from multiple levels of the organization. And basically at this stage, the concept of computer security evolved into the more sophisticated system that what we now refer to as information security. This slide basically I wanted to demonstrate some key points or key dates for some seminal works in early computer security, starting in '68 with Wilkes discusses password security. Shell, Downing, and Popick examined the need for additional security in military systems. In '75, the Federal Information Processing Standards examines digital encryption standard, or DES. And then Bisbee and Hollingworth in '78, Morris and Thompson were the authors of Password Security and Case History. Still, we're still really looking at some rudimentary technological or security tools like passwords. Ritchie published on the security of Unix and the protection of data file contents, really discussing secure user IDs and secure user group IDs and some of the problems that were inherent in that system. And then, Graham and Morris write Unix operating system security. Reed and Weinberger published file security and the Unix system crypt command. And that kind of moves us through those 2 decades. And then, we really roll into where it becomes a burgeoning field in the 90s with the, the development of and the creation of, home personal computers, where we have networks of computers became more common. And so too did the need to connect the computers to each other, hence this is where we move into the World Wide Web. This gives rise to the internet, first manifestation of a global network of networks. There has been a price for this phenomenal growth of internet. However, when security was considered at all, early internet deployment treated it as a low priority. What the goal was connectivity at the time, and as we'll talk about, there's always going to be a trade-off between connectivity and security. And when the internet was burgeoning and developing, security was very much a low priority. As the requirements for network computers became the dominant style of computing, the ability to physically secure the physical computer was lost. And the stored information became more exposed to security threats. From 2000 to present, obviously the internet has brought millions and millions of uncensored and unsecured computer networks into communication with each other, and our ability to secure computers' stored information is now influenced by the security on each computer to which it's connected. So you're only as secure as the least secure computer that you connect to. Let's talk about what is security, or what do we think security is. And I guess if we were to look for a definition of security as the quality or state of being secure, to be free from danger. It means to be protected from adversaries, from those who would do harm, intentionally or otherwise. A successful organization really needs to have multiple layers of security in place for the protection of operations. And when we look at information security, we have to take in consideration all of these levels of physical security, to protect the physical items, the objects, the areas of an organization, unauthorized access and misuse. Personal security, protection for the individuals or groups of individuals who are authorized to access the organization and its operations. Operation security, to protect the details of a particular operation to series of activities. Communication systems security, to protect the organization's communications media, the technology and the content. Network security, to protect the networking components and connections and contents. And then information security, really looking at the protection of the information that's used across the organization's networks. Information security, therefore, if we really look at it, is the protection of information and its critical elements, including the systems, the hardwares that store and use and transmit that information. But to protect the information and its related systems from danger, tools such as policy, awareness, training, education, and technology are necessary. In this field, we really fall back to three critical elements, and that's the CIA triangle, which is considered the industry standard for computer security since the development of the mainframe, and it was based on three characteristics that describe the utility of information: confidentiality, integrity, and availability. Today, the triangle has expanded into a list of critical characteristics of information. Critical characteristics of information, the value of information, comes from these characteristics that it possesses, right? The availability, which enables users who need access to the information to do so without interference or obstruction, and in the required format. The information is said to be available to an authorized user when and where needed and in the correct format. Accuracy refers to the state or the characteristic of being free from mistake or error, having the value that the end user expects. If information contains a value different from what the user expectations are due to the intentional or unintentional modifications of its content, it is no longer considered accurate. Authenticity is the quality or state of being genuine and original rather than a reproduction or fabrication. Information is authentic when it is the information that was originally created, placed, stored, and transferred. Confidentiality is the quality or state of preventing disclosure or exposure to unauthorized individuals or systems. Integrity is the quality or state of being whole, complete, and uncorrupted. The integrity of information is threatened when the information is exposed to corruption, damage, destruction, or other disruptions of its authentic state. And then utility is the quality or state of having value or some purpose or end. Information has value when it serves a particular purpose. This means that if information is unavailable, if information is available, but not in a format meaningful to the end user, it is not useful. And finally, possession is a quality or state of having ownership or control of some objects of some object or item. Information is said to be in the possession of one obtains it independent of format or other characteristics. While a breach of confidentiality always results in a breach of possession, a breach of possession does not necessarily result in a breach of confidentiality. And we'll talk about that a little bit, because as we apply security controls, you'll see that some security controls may affect one or two of these characteristics, but it might not necessarily impact all of them. And that's important when you're selecting those security controls, and when we're talking about them, that you understand that there's really weaknesses and strengths that are associated with each of them. This graphic here really looks at the fundamental approach of information security, and can be used to illustrate the intersection of information access, right, along the x-axis, key objectives of the CIA triad along the y-axis, and the three primary means of implementation of security, with its policy, education, and technology. And when we talk about information security in this course and in the next course, CBY610, and then some of the other courses like policy and laws and legislation, you really should come back to the McCumber Cube and think about how is this relating to the confidentiality, integrity, availability of information, and access in those three areas: storage, processing, and transmission. And then it sometimes helps us remember, really how it works. components of information systems. And when we talk about an information system in the concept that we have here, it's the entire set of components. It's necessary to review each of these to make sure that we really are on the same sheet of music. But it's much, much more than just the technology, just the computer hardware. It's the entire set of software that runs on that machine. It is indeed the hardware. It's the data that is resident and moving across that network and resident on the machines. It's the people that interact with those devices. It's the procedures, and then obviously the network as well. So we want to make sure when we talk about information systems that we talk about it in the scope that it really is, in, looking at all of the 6 different elements. And then when we talk about information security, we have to address each one of these elements as well. You will see as we move through the content of this course, and you begin to talk about it in other courses, that really when considering information security, it's important to realize that it's impossible to obtain perfect security. Security is not an absolute. It is a process, but it is not a goal. Security should be considered a balance between protection and availability. And to achieve that balance, the level of security must allow reasonable access, yet protect against threats. And that's the constant struggle. We can certainly make things very, very secure, but we may very well make that information unusable or unlikely to be productive in the business environment because it's so difficult to get to. A couple of different ways that we can implement security or information security across an organization. And there's a bottom-up approach and a top-down approach. And each have its pros and cons. A bottom-up approach is really an effort that is guided by the system administrators in an attempt to improve security of their systems. The key advantage to the bottom-up approach is that the technical expertise of the individual administrators makes the technical implementation of a bottom-up approach very easy. Unfortunately, this approach seldom works. It lacks a number of critical features such as participant support and organizational staying power. In other words, system administrators within an organization generally do not have the influence to make people do the things that need to be done in order to secure a system. We flip the coin over and we look at the the top-down approach. This has a higher probability of success, where the project is initiated by upper management, who issue policies, procedures, and process. They dictate the goals and expected outcomes of the project, and they determine who is accountable for each of the required actions. This requires a strong upper management support, a dedicated individual to champion the effort, dedicated funding, clear planning, and really the opportunity to influence an organization's culture of security. The most successful top-down approach involves a formal development strategy referred to as a system development lifecycle or a security system development lifecycle, which we'll talk about. Here's a little graphic to show you the difference, where top-down approach is really driven from the C-level down to the bottom, and a bottom-up approach starts at the bottom with the network technicians, the security administrators, and so forth, and they work their way up. Talk a little bit about the security system development lifecycle. It's the same basic phases that are used in the traditional system development lifecycle. The key concept here is that we are really looking at using the fundamental process identified, the process that is the identification of specific threats and the creation of specific controls to counter those threats. The security system development lifecycle unifies the process, makes it a coherent program rather than a series of random and seemingly unconnected actions. And this is why, if you look at the curriculum here at BayPath, we have put in place a course that's about project management as it relates to security or information systems and information system security, because it's such a critical component of developing a secure system that we felt it was necessary that you actually take an entire course in it. If we look at the first phase of the system security development cycle, we're talking about investigation, and it begins with a directive from upper management, basically dictating the process, the outcomes, the goals of the project, as well as any constraints that might be placed on the activity. Frequently, this phase begins with a statement of program security policy that outlines the implementation of security. Teams of responsible managers, employees, contractors are organized. Problems are analyzed. The scope is defined, including the goals, the objectives, the constraints not covered in the program policy. Finally, in this phase, an organizational feasibility analysis is performed to determine whether the organization has the resources and the commitment necessary to conduct a successful security analysis and design. The next phase in this cycle is the analysis phase, and here the documents from the investigation phase are studied. The development team conducts preliminary analysis of existing security policies or programs, along with documented current threats and associated controls. This is the risk management process that you'll talk about later. This phase also includes an analysis of any relevant legal issues that could impact the design of the security solution. Risk management task is initiated by identifying and assessing and evaluating the levels of risk facing the organization, which is a key component of moving any process forward or any security process forward within an organization. The next phase is the logical design. And here we create and develop the blueprints for security. It examines and implements key policies that influence later decisions. Also at this stage, critical planning is developed for incident response actions to be taken in the event of partial or catastrophic loss. And part of that process is a continuity plan, an incident response plan, and a disaster recovery plan. All of these things that we'll talk about in later modules. And next, at the end of the logical design, we do a feasibility analysis to determine whether or not the project should continue or should be outsourced. The next phase of the life cycle is the design. Here, the security technology to support the blueprint outlined in the previous. The security blueprint may be revisited to keep it synchronized with the changes needed when necessary. Criteria needed to determine the definition of a successful solution is also prepared during this phase. Including at this time are the design for physical security measures to support the proposed technology. And at the end of this phase, we're going to do another feasibility study to determine if the organization is ready for this. And all parties involved will also have a chance to approve the project before its implementation. And remember, when we talk about this security function within an organization, the most well-rounded team is going to have representation from a variety of different parties of interest within an organization. It's not just the IT folks and the security folks. It's going to be members of management. It's going to be line personnel. It's going to be support personnel. It's going to be somebody from accounting and finance and maybe manufacturing that really will sit down as a group and look at, does this security control really do what we want it to do? The next phase that we'll talk about is implementation. The security solutions are acquired. They may be purchased or they may be built, tested, implemented, and tested again. Personnel issues are evaluated. Specific training and education programs are conducted for individuals that might need it in order to make sure that the system operates the way they would want it to, or for those individuals that have to interact with it on a day-to-day basis. And finally, the entire package is tested and presented to upper management for final approval. And finally, the maintenance and change, where we look at this phase as the last phase, but perhaps the most important given the high level of ingenuity in today's threats. We have to make sure that the reparations and restoration of information is a constant duel with often unseen adversaries. So we want to make sure that when we put a system in place, we do not forget that it's not a one and done type of situation. We must always make sure that any control that we put in place has appropriate maintenance and has the ability to change and evolve as the threat scenarios that it faces also change. As new threats emerge and old threats evolve, the information security profile of an organization requires constant adaptation to prevent threats from successfully penetrating its sensitive data. So it's cyclical in nature. It's not a one and done. Security professionals in the organization, it takes a wide range of professionals to support the diverse information security program that any organization has. It's a lot of specialties, and there's still individuals that need to be very diverse in their understanding of the entire role of information security. To develop and execute specific security policies and procedures, additional administrative support and technical expertise is required. So as a profession, it is also not a one and done. This is a profession of constant education. You must always remain current. You must always be educating yourself as to the newest threats, the newest controls that are available. Your management that within an organization, some of the titles that you might see is Chief Information Officer, the Senior Technology Officer, although other titles like Vice President of Information, Vice President of Information Technology, Vice President of Systems may be used. Their primary responsibility for advising the Chief Executive Officer, the President, or company owners on the strategic planning that affects the management of information within the organization. Usually reporting directly to them is the Chief Information Security Officer, and this is the individual who's primarily responsible for the assessment, management, and implementation of securing the information within the organization. They sometimes are referred to as the Manager of Security, the Security Administrator, or some similar title. Look at a project, an information security project, and the names come under a bunch of different not specific to an organization. It's not an industry standard, but generally you have an individual who's a champion, which this would be a senior executive who promotes the project and ensures that it supports both financially and administratively at the highest level of the organization. Team leaders are project managers who may be a department line manager or a staff unit manager who understands project management, personnel management, and information security technical requirements. Policy developers are individuals who understand the organizational culture, policies, and requirements for developing and implementing successful policies. Risk assessment specialists are individuals who understand financial risk assessment techniques, the value of organizational assets, specifically information assets, and the security methods to be used. Security professionals are dedicated, trained, and well-educated specialists in all aspects of information security, both from technical and non-technical standpoints, and then system administrators, who are the people that are primarily responsible for administering the system that houses the information used by the organization, and then finally end users. And these are the individuals who the new system will most directly impact. Ideally, a selection of users from various departments or levels and degrees of technical knowledge will assist the team in focusing the application on focusing on the application of realistic controls applied in ways that do not disrupt the central business activities they seek to safeguard. So when we look at implementing a security control within an organization, these are the basic individuals that we would want to see involved in it. It involves individuals from every aspect of the organization to ensure that the control does what it is supposed to do. So let's talk a little bit about data and the responsibilities of it. Who owns data? Now that you understand basically the responsibilities of both senior management and the security team, we can also define the roles of those individuals that really own and safeguard data. If we look at a data owner, this is the individual that's responsible for the security and the use of a particular set of information. Data owners usually determine the level of data classification associated with the data, as well as changes to that classification required by organizational change. Data custodians are responsible for the storage, maintenance, and protection of the information. The duties of a data custodian often include overseeing data storage, backups, implementing the specific procedures and policies laid out by the security policies and plans, and reporting to the data owner. Data users are the end users and system users who work with the information to perform their daily jobs during the mission, supporting the mission of the organization. Everyone in the organization is responsible for the security of data. So data users are included here as individuals with an information security role. Many times one person might fill more than one of these roles. Sometimes there's one particular person that is responsible for all of these roles, and it's your job and the information security team's job to understand who is responsible for it and make sure that you're putting controls in place to help guide these individuals in the appropriate tools and techniques to protect the data that an organization might own. Sometimes we look at groups or individuals as communities of interest within an organization. Each organization develops and maintains its own unique culture and values. Within that corporate culture, there are communities of interest, and these include things like information security and management and professionals, information technology management and professionals, organizational management and professionals, and also individuals like end users or departments or particular functions within there. So we have to make sure that when we start talking about information security, that we address all of the individual communities of interest. Now we get into a little bit of debate as far as what really is information security, and one of the ways that we can look at it is in art or science. With the level of complexity in today's information systems, the implementation of information security has very often been described as a combination of both. The concepts of security artisan or security professional is based on the way individuals perceive system technology since the computer became commonplace. It is both. It is a science because there are standards, there are certain ways of doing certain things, but it's also very much an art in that it has to be tailored towards an individual culture of an organization. Because there are no hard rules regulating the installation of various security mechanisms, nor are there many universally accepted complete solutions, but there are many manuals to support individual systems. Once these systems are interconnected, there's no magical user manual for the security of an entire system. This is especially true with complex levels of interaction between users, policy, and technological control. So there is a bit of art to information security. As a science, we are dealing with technology, right? We're dealing with technology developed by computer scientists and engineers, technology designed to perform at a rigorous level of performance. Even with the complexity of the technology, most scientists would agree that the specific scientific conditions cause virtually all actions that occur in a computer system. Almost every fault, almost every security hole, and system malfunction is a result of interaction of specific hardware and software. If the developers had sufficient time, they could resolve and eliminate many of these things, but that's just not the case. That's not the way the information technology field operates. So it could be an art, it could be a science, but it could also be a social science. And really what we're talking about here is the social science examines the behavior of individuals as they interact with the systems, whether societal systems or, in our case, information systems. Security begins and ends with the people that interact with the systems, planned or otherwise. End users that need the very information that the security personnel are trying to protect may be the weakest link in the entire security chain. By understanding that some of the behavioral aspects of organizational science and change management, security administrators can greatly reduce the level of risk caused by end users and create more acceptable and supportable security policies. So if we look at it as a social science or understanding how humans behave and how humans interact with technology, we might be farther ahead than looking at it as an art or a science. In summary, information security is a well-informed sense of assurance that information risks and controls are in balance. It began immediately after mainframes were developed. Successful organizations have multiple layers of security in place: physical, personnel, operations, communications, network, and information. It should be considered a balance between protection and avoidance. It must be managed similar to any major system implemented by an organization using methodology like the security system development lifecycle, which is cyclical in nature. Implementation of information security, often described as an art and a science, but more likely social science. Thank you very much.